Hi everyone, welcome back to Lifey Technologies YouTube channel, and thank you for watching and supporting our channel. So we are continuing with our Nokia Lab simulations, and in our last episode we have demonstrated how to configure OSPF protocol on Nokia routing devices. So if we check on these routers from R1 and show router OSPF 10 neighbor, you can see that we have a neighbor to R2. We can show the OSPF configuration, configure router OSPF 10 info. These are the configuration that we have on this router. It's configured to be in area 1, and the area ID is also configured. We have enabled OSPF on the interfaces. So you can show router OSPF 10 interface. You have these interfaces configured with OSPF. So on R2 we can do the same. Show router OSPF 10 neighbor. We have this neighboring relationship established, R2 to R1, R2 to R3. Show router OSPF 10 interface. We have these two interfaces to R1 and to R3 enabled, and even the system interface enabled with OSPF. We can show router route table protocol OSPF. You see the routes we are getting from OSPF. On R3 we can do the same. Show router OSPF 10 neighbor. These are the neighboring relationship that we have on this router. Show router OSPF 10 interface. So we have the interface to R2 and to R4 configured with OSPF. We can check the OSPF configuration on this router also. Configure router OSPF 10 info. So you can see that we have two areas. We have area 0 and area 2. The interfaces have been enabled on these two areas. Show router OSPF 10 route table routes. You can see the route that we are getting via OSPF. You can also check the global routing table. Show router OSPF 10, show router route table, protocol OSPF. You have the routes learned via OSPF. So on R4 we can also verify the same. Show router OSPF 10 adjacency. You have a neighboring relationship to R3. Show router OSPF 10 interface. You have the two interfaces, system and to R3. Show router OSPF 10 routes. So you have the routes learned via OSPF. We can also verify our LSDB. Remember, once we have formed our adjacencies, we have the LSDB database that is populated with the different LSAs exchanged between different routers. So if we check on R1 exit, show router OSPF 10 LSDB, or we call it the database, you can see that we have different LSAs. We have route LSA, network and summary LSA populated on this router. On R2 we expect to have a similar table, so we run show router OSPF 10 database. We have the LSAs, we have the router, the summary, and the network LSA. On R4 we do the same. Show router OSPF 10 DB. We have the LSAs populated from the router, network, and summary. So this one confirms that our OSPF configuration are okay and our adjacencies are okay. So in this episode, we are focusing on how OSPF does the DR and BDR election and also the network types on Nokia routers. So if you haven't watched the previous video with clear demonstration of how to configure OSPF, you can check it out on our channel and have a look at it. It will help you to have a better understanding of this episode. So why do we need the DR and the BDR? So in a normal broadcast network, remember OSPF supports different network types. We have the broadcast network, we have the point-to-point, and then we have the non-broadcast. So for the broadcast and unbroadcast, we normally elect the DR and the BDR to help us to minimize the number of adjacencies that we need to establish in our network. So without the DR and the BDR, you can see in such a setup with just 8 routers, you have to establish so many adjacencies in your OSPF network. So it ends up consuming some network resources. So that's why we need the concept of DR and BDR in OSPF. The DR stands for designated router. The BDR is the backup designated router. So the DR and the BDR will be in charge of exchanging the LSAs in the network. And then the other routers, we call them the DR other. So they don't establish any adjacencies. They only have the neighbor relationship, but no adjacencies. So how do we elect the DR and the BDR? The DR and the BDR is elected first. We consider the priority. So if we were to check on R1, show router OSPF 10 interface, you can see that the interface to R2 is selected at the DR in this setup. So we expect the interface, we check on R2, show router OSPF 10 interface. You can see that the interface to R1 is the backup designated router. So we have the DR, this is the DR IP, and then we have the backup DR IP. So if we display the details, so I've mentioned that the first thing that we normally check when doing the DR and the BDR election is the priority. So we check the interface priority. If we do interface detail, you can see we are focusing on our interface to R2. So the priority is set 1. So this is the default priority on Nokia routing devices. It will always be 1. But then if it's the default, then it means the two neighboring routers will end up having the same DR priority. So whenever there is a tie, sometimes, or whenever there is a tie, by default it will check the interface with the highest IP. So the interface with the highest IP will be elected as the DR. But sometimes the DR and the BDR election also depends on some factors. Maybe which router first send the messages, or which interface came up first. So sometimes you may end up not being able to control just by setting the priority. So sometimes, especially when you set the priority, you always have to restart the process. Remember, in this setup, we have the DR priority set 1 and 1. But if you check on the DR election, you can see that we have, just 1 second. So you can see that we have this set 1. If we check on R2, show router OSPF 10 interface detail, we check the interface to R1. So the interface to R1 also has a priority of 1. So the priority cannot be used to determine who will be the DR or the BDR. So one thing that we normally do is to change the priority. So we change the priority to a higher value, and then the router will be elected at the DR, and then the one with the second highest will be elected at the BDR. So how do we change the priority? So for us to demonstrate how to change the DR and the BDR priority, we'll be using R1 and R2. So on R1, we verified that our priority is 1. Just show router OSPF 10 interface again. So configure router OSPF 10. This is area 1 info. So if you do info detail, let me go into this interface to R2 info detail. You can see that the priority is set to 1. So for us to change the priority, you just need to run the command priority maybe we need to do this configuration on R2. Remember, currently R1 is the DR, so we can do the configuration on R2 to force it to be the DR. So configure router OSPF 10 area 1 info, then interface to R1 info detail. You have the default configuration. The priority is set to 1. Info again, so we can set the priority and the value ranges from 0 to 255. So a higher value will be preferred. If you set the priority to 0, it means that the router will not participate in the DR and the BDR election. So we can demonstrate this after controlling the DR and BDR between R1 and R2. So we can set the priority to the highest. We can set it to maybe 200 info. So as much as we have changed the priority to 200, the DR and the BDR will not change. There is no preemption when it comes to the DR and BDR election. So the only way we can impact the DR and BDR election is by restarting this OSPF process. So still, if I show router OSPF 10 interface, you can see that this router, it's still the BDR. Detail, we need to check the interface to R1. You can see the priority is now set to 200, but again, it's still the BDR. It's the backup designated router, because there is no preemption when it comes to the DR and the BDR election. So one thing we can do is exit. We can info again. We can shut down the OSPF or even shut down the interface. I'll just shut down the OSPF so that we re-establish the peering session between the two routers. I will now shut down. Info, exit. So show router OSPF 10 neighbor. Our relationship is now full. Show router OSPF 10 interface. It's still elected as the BDR. We need to configure router OSPF 10 info. Let me check on R1. Exit info. Show router OSPF 10 interface. So this is still the DR, so I will shut down the OSPF from this end and see. So show router OSPF 10 interface. Operation state is currently down. Let me now shut down the OSPF process. Show router OSPF 10 interface. So you can see that now the interface to R2 has changed the operation status to the BDR, because now R2 has a higher priority. So we have managed to change the DR from R1 to R2. So this is now the BDR in this network. So what happens if we change the priority to 0? I've mentioned that if we change the priority to 0, we are making the router not to participate in any DR and BDR election. So it will be a DR other, and it will never be a DR or a BDR. So if you check currently, we don't have any priority configured. And on R2, we can verify that R2 is now, if you check up here, show router OSPF 10 interface. You can see that to R1 is currently the DR. Our R1 show router OSPF 10 interface is now the backup designated router. So what I want to do is to change the DR priority to 0 for this R1, and it will become a DR other. Immediately we change the priority. So we'll configure interface. We need to be under area 1 interface. So info detail, no priority configured, priority set to 1, and I changed the priority to 0. So immediately I configure this show router OSPF in OSPF 10 interface. You can see that now it's the DR other because the priority is set to 0. So if we do detail, you can see that the priority is set to 0. We check on the interface, yeah, the priority is set to 0. So it will never participate in the DR and the BDR election. Now, if we check on R2, remember, it was giving this IP as the backup designated router. So we can check again. You can now see that we don't have the backup designated router. So whenever you set the priority to 0, it means the router will never participate in the DR and the BDR election. So that is it on the DR and BDR election. The next thing that we need to do or to check is how to configure the network types. So I have mentioned that OSPF supports different network types. We can have broadcast, the one that we have. So by default, it will be set to broadcast. If I check info detail, you can see that on this interface configuration, let me just go into an interface. Interface need to be under area 1, area 0, interface to R3, info detail. So you can see that we haven't configured any interface type. But if we show router OSPF 10 interface to R3 and add the detail, down here we see that the interface type or the network type is set to broadcast by default, and the network type is transit. So when you are configuring the network type, you always have to merge. Like you cannot have a relationship being established when one end you have a network type of point to point and then other side you have a broadcast. So you always have to merge. If it's a point to point, then make it point to point. If it's a broadcast, then make it a broadcast on side A and a broadcast on side B. So for us to be able to configure the network type, I will be changing the network type between R1, R2, and R3. So on this router, if I were to change the network type on R2 to be point to point, and many times, by the way, we normally configure the network type to be point to point, especially for these links that are only interconnecting two routers. We normally set the point to point network type. So I will interface type. You can see that we have 3 types. We have broadcast, it's kind of you are connected to a switch, point to point, and non-broadcast. So if I change this network type to be a broadcast, I mean to be point to point, the peering relationship between R2 and R3 should be down because they are incompatible. So I will change it to point info. So you can see that we now have the interface type set to point. I can show router OSPF 10 adjacency. You see that we now only have a peering relationship to R1. I don't know whether we show router OSPF 10, then we see whether we have the errors like we did on Huawei. Not sure. Status maybe. Statistics. Bad areas, but I need to check on this. But info, so we have configured the network type to be point to point. And if I show router OSPF 10 interface, it's interface to R3 detail, you can see that configured interface type is point to point. It's a point to point. The network type has also changed to stub. While the other side, it's a broadcast, so the relationship will not come up. So for us to be able to bring up the peering relationship, we need to change the network type from this end. So it's interface. I need to go to area 0, info, interface to R2, info. We change the interface type to point, info. So now on R2 we expect the peering session to come up again. Show router OSPF 10 neighbor. You can see that now our neighbor relationship is up, and even we are able to show router OSPF 10 interface detail. So we have an interface of point to point between the two routers. So this is how simple it is to configure the network type and also to control the DR and BDR. Remember, for the DR and BDR, we are using the priority. So you just need to change the priority on the router that you want to be the DR and the BDR. You make it higher. And then those ones that you don't want to participate in the DR and BDR election, especially for the edge routers. For example, in this setup, we don't want R1 to be the DR at all, because it will be suboptimal. So we can configure R1 and R4 not to participate in any DR and BDR election. And then for the network type, you can always specify the network type using the interface type, and then you specify the one that you want, point to point, broadcast or non-broadcast. By default, it is always a broadcast type. So for the configuration, info, exit again, info, you can see that we did configure priority, and then we configured the network type to be point to point. So this is it for this episode. I hope you've enjoyed it. If you have, please like the video, leave your comment in our comment section. And also just a reminder that if you haven't subscribed to our channel, hit that subscribe button and stay tuned for more upcoming videos. Thank you.